Hello students, welcome to my channel. Hope you have watched my last videos, and today's my topic is formation of single, double and triple bonded covalent compounds. Let us discuss first, that is single bonded covalent compounds. Taking an example of chlorine molecule, it consists of two atoms of chlorine. According to electronic theory of valency, chlorine has atomic number 17 and its electronic configuration is 287. Here its nucleus, this is the K shell, this is L and this is M. In a K shell it consists of 2 electrons, in L shell it consists of 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8. While as in the outermost shell it consists of 7 electrons, 1, 2, 3, 4, 5, 6, 7. It indicates that it has 7 electrons in its outermost shell. That means it is unstable. For its stability, it needs one more electron so that make it stable. Here we can say it is Cl plus Cl consists of 2, 8, 7 electronic configuration, 2, 8, 7 electronic configuration. These are two chlorine atoms. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Now these two chlorine atoms will share each other 1 electron each and gives a 1 pair of electron and forms a single covalent bond between the chlorine and the chlorine. Now see here, it is Cl here, Cl 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Now it became here 2, 8, 8. 2, 8, 8. This is called configuration of argon. That is 2, 8, 8. It is an inert gas, and also we can say it's an inert gas configuration of argon. And here you have seen two dots, that means it consists of a single covalent bond. This single covalent bond is called one pair of shared electrons between two chlorine atoms forms a single covalent bond. Single covalent bond, and we can write down this Cl single bond Cl or Cl2. Here it is now stable because it consists now 288. That means it is stable. The bond the bond between these two formed is known as covalent bond, and this single covalent bond is a very strong bond, which holds these atoms together by a strong force, and this strong force is known as a covalent bond. Now let us go with the diagrammatically, that is, here we can see it is a nucleus. This is the outermost shell of the chlorine atom. It consists of 7 electrons, 1, 2, 3, 4, 5, 6, 7. Plus one more chlorine atom, 1, 2, 3, 4, 5, 6, 7. Here 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Here you have to count these two dots, these two electrons for both the chlorine. So we can count like this: 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. This means this is sharing. This sharing is known as covalent sharing of electrons. Same here. These are outermost shells of chlorine atoms. 2, 8, 7. 2, 8, 7. Here you will see 2, 8, 8, 2, 8, 8. And this stability resembles with the inert gas configuration of gas configuration of argon, that is 288. Let's take now CH4. CH4 is known as methane. According to the electronic theory of valency, we can find the formation of methane molecule. Here it consists of one carbon atom and four hydrogen atoms. Now the electronic configuration of carbon is 2 and 4 because its atomic number is 6, while as hydrogen has its electronic configuration, that is 1, because its atomic number is 1, which means that carbon has 4 electrons in its valence shell, and this is also known as the valency of carbon. If we can say it consists of 4 electrons in its valence shell, that means for stability purpose it requires 4 more electrons to make it stable to the nearest inert gas configuration. And here hydrogen has 1 electron in its outermost shell, that means it also needs 1 electron to make it stable. For this purpose, to make them stable, let us take how they will go for the stability. Here we can write down C, that is 1 electron, 2 electron, 3 and 4. This is here carbon with 4 electrons in its outermost shell, plus 4 times hydrogen with 1 electron in hydrogen's outermost shell. Now we can say there are 4 electrons. We can write down like this also: 1, 2, 3 and 4. That means there are 4 electrons in hydrogen, and we have got here 4 electrons in carbon. Now it will give an easy task for now, that they will go for the sharing. That means these 4 electrons will share with these 4 carbon electrons, and giving the shape of methane molecule like this. It is in center, you will find C. Now here 1, 2, 3, 4, 5, 6, 7, 8. H, 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 H. Here the 4 electrons of carbon atom had got sharing with 4 electrons of hydrogen, and gives the formation of methane molecule. And with the help of this formation, you will see here there will become 4 pairs of shared pairs of electrons. Number 1, number 2, number 3 and number 4. All of you have seen these 4 pairs of electrons having 1 pair each. That means it has single bond. We can write down this methane molecule also: C, single bond H, single bond H, single bond H, single bond H, or CH4. This is the formation of the methane molecule. Now let us go for the double bond, now we can go double bonded covalent compounds. Double bonded covalent compounds. Taking an example of oxygen molecule, that is O2. According to the electronic valency theory, we can say oxygen, the atomic number of oxygen, atomic number of oxygen, oxygen is 8. Electronic configuration is 2 and 6. That means in K shell it consists of 2, while as in L shell it consists of 6. It means that one atom of oxygen contains 6 electrons in its outermost shell. If you can say it consists of 6 electrons in its outermost shell, that means to make it stable, to be stable, it needs 2 more electrons to form stability as an octet. Now here we can see how this is possible. Taking as an one atom of oxygen plus second atom of oxygen with electronic configuration, and the outermost shell has got the 6 electrons. That means 1, 2, 3, 4, 5 and 6. 1, 2, 3, 4, 5 and 6. Here we can say it is unstable. These are 2 oxygen atoms. You can write down here 2 oxygen atoms. Electronic configuration 2 and 6. 6 is the outermost shell. 2 and 6. 6 is the outermost shell. Gives the formation of oxygen molecule. But here these 2 oxygen atoms, when shared each other, giving 2 pairs of electrons, which forms the double covalent bond. Let us see how. Here 1, 2, 3, 4. Oxygen, oxygen. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Here you have to count these 4 electrons for the both 2 oxygen atoms. Here you will see this is the, here you can see these 4 electrons shows the formation of double covalent bond, and here it is 2 and 6 unstable. Now it is here stable. It becomes 2, 8, 2, 8. That is very nearest, which resembles the neon gas configuration. The another term, that is triple bonded covalent compounds. Triple bonded covalent compounds. Taking an example of nitrogen molecule. It consists of 2 atoms of nitrogen. 2 atoms of nitrogen. according to the electronic theory of valency, nitrogen has atomic number 7 and its electronic configuration is 2 and 5. That means it consists of 2 electrons in a K shell and 5 electrons in its outermost shell. So for the formation of nitrogen molecule, it requires 3 more electrons to attain noble gas configuration of its nearest inert gas. In this regard, we will see how it will share. Taking nitrogen molecule, nitrogen atom plus nitrogen atom with 5 electrons, 1, 2, 3, 4, 5. 1, 2, 3, 4 and 5. That means it consists of 5 electrons in its outermost shell, 5 electrons in its outermost shell. These are called 2 nitrogen atoms with 5 electrons in their outermost shell. When these 2 nitrogen atoms will share each other, they will form nitrogen molecule. With the help of, they will share 3 pairs of electrons each, so that they will get the stability. For this purpose, to make them stable, let us see here. Now N, 1, 2, 3, 1, 2, 3, here is N. 1, 2, 3, 4, 5, 6, 7, 8. 7, 8. Here he has to count these 3 pairs in both the nitrogen. That means how we can count? See here. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. That means this is called the sharing of 3 pairs of electrons between the 2 nitrogen atoms. Now here we can see the position now. 1, 2, 3, 4, 5, 6, 7, 8. That means octet. 1, 2, 3, 4, 5, 6, 7, 8. This is also the octet. That means it is now stable. For the stable purpose, we have got the formation of nitrogen molecule. Here you can write down this nitrogen molecule like this, N triple bond N. Why? Because we know that double 2 dots in one pair of electrons means single bond. 2 pair of dots, that means 4 dots, means double bond, while as 3 pairs of dots, 1, 2, 3, 4, 5, 6, and that means 6 dots means triple bond. So why we write here N triple bond N? This is the formation of N2, that is the molecule of nitrogen. This configuration is also known as the neon configuration. Neon configuration, because it resembles its configuration with neon, and this was the formation of nitrogen molecule. Hope you enjoyed today's lesson and share the video with your fellow students. Thank you so much.